Hey, Matt.
Hey, Mike.
Hey, Richard.
Hey, Mike.
Hey, Richard.
Hey, Matt.
Would y'all like to do a podcast?
Yeah.
Sure.
Let's do it. Welcome to Hacking the Grepson, where today we have a special guest. Special guest, introduce yourself.
I am Richard. I am a software engineer, like all the present. I do a bunch of stuff related to tools for fusion research.
Ooh.
So that is what I do.
Okay. That's fancy. Wow, I don't think I've ever used any kind of fusion or fission in my career. How about you, Matt?
Nope. Some nuclear power, I guess, was maybe on some of the stuff when I was working for a defense contractor, but I didn't work with it.
I suppose at the research institution that I work at, there might be some fusion or fission going on, but I am not responsible for it. So
there definitely is, because I have a contract with where you work, and it is fusion related.
Wow, all of the timelines are lining up here.
Yeah.
So today on the show, we're going to talk about Advent of Code again, but with our guest Richard, who has been doing it with us. You may have remembered us mentioning him here and there as we talked about the previous days, but now he's here in the quote-unquote studio with us. So we're really happy to have him here and get another direct line on the insanity that is helping elves make Christmas happen. I mean, we're recording this in 2024, so Advent of Code 2023 is done, but that doesn't mean we can't still talk about it. So we figured we would wrap up the final 16 days, 11 to 25, since we did 1 through 10 already, and we're just going to go over some problems and figure out some blocks falling and some mirroring lines and communication dishes, and I don't know, man. It's been a few weeks since I've looked at these. I can't even remember some of them, but I guess it'll all come back to me as we go over it. So, Richard, since you're new to the podcast today, would you like to take the first day?
That's day 11, right?
Yep.
Day 11.
So day 11 was cosmic expansion, and the elves are in an observatory, and they are looking out to try and find the distance between these. Let's see. What are they looking for?
Galaxies, I think?
Galaxies? Oh, yeah. There's a bunch of different galaxies, and the universe is expanding, and for some reason they need to find the distance between these galaxies. And so wherever there is empty space, the universe is expanding. And so you need to go and find what they called the shortest distance, which would to bite me a bit later, but between each of these. Because originally I thought it might be a pathfinding problem, and it most definitely was not.
Yeah, I had that same sort of reaction when I first saw it. I think you even said, no, it's not. It's not that bad. It's what is it, taxi distance or something silly like that?
Yeah, the taxi cab distance between galaxies. It's not a graph problem. Not a graph problem.
Well, that's because it was only day 11. But I
Yeah,
feel
so
like
later.
Yeah, I feel like later days, that's when the graph analysis comes up. So how did you handle this, Richard? Because I'm trying to remember how I did it.
So I basically went through and I moved each of the galaxies that were before a certain threshold in that direction, like in a negative direction. And this is whenever there would be like blank space in between an entire row or column of galaxies. And then afterward, I just took their new locations of the galaxies, and found all the distances and added them up and submitted them.
You make it sound so easy. What about you, Matt?
I'm trying to figure out what I meant by this note. I found this one, like, when I first read it, it seemed pretty daunting. Again, for similar reasons to what Richard said about, like, oh no, shortest paths. As soon as I see that, if the word Dijkstra pops into my head, I'm like, do I really want to do this right now? But it turned out not to be that.
Yeah,
which was
someone
nice.
messaged me like that was also on our leaderboard that was like, "Hey, did you use the Dijkstra's algorithm?" I'm like, "I'm pretty sure you're misreading this problem."
I ended up doing the expansion with math on the overall universe size and each individual galaxy location rather than actually having a grid. I think I tried to make a grid at one point and went, oh, that's going to get real big real fast. And so then I just ended up with math and calculating locations of individual galaxies. If I tried to have the location of the individual the empty space tiles, that's where it got kind of screwed up, at least for part one.
I did a similar thing but I actually did go with the grid option, making a grid, which of course, yeah, when we get to part two, because part two is big numbers, which, that's often part two in Advent of Code, where you spend all the time trying to come up with an algorithm, but if it's not optimal, then part two throws much bigger numbers at you that kill your algorithm, which is what happened to me. But go ahead, Richard, what were you going to say?
Oh, I was just going to mention, this is the one, I believe, where you had the festive screenshot, right, Matt?
I think so. I was looking back at my picture. Yeah, I've got like red, white, green, blue, and purple, or magenta, I think, technically. I don't remember what any of the colors other than green represent. Oh, I see what it is. It was green was the individual galaxies, and then red was if I expanded a column, blue was if I expanded a row, and purple was if it was both, so that I didn't double count.
Yes, and I followed through with that as well. If for nothing else, it's pretty.
Yeah.
So part two, we're all alluding to the big number of part two. Did that bite anybody in the butt?
There was a couple bits of logic errors, I guess, that I had in my in my code, since I just had a increase by 1 when I was expanding in the previous, and it actually needed to like double in size the distance between things, and I just think I got lucky. And then of course I had some other off by 1 error, and then I think as an optimization I had to switch over to using multiplication instead of addition, going along with the whole doubling in size thing. But overall, it ended up being relatively straightforward, given how I did part one. How about you guys?
For part two, I don't know if we mentioned it yet, but you were supposed to go, oh, it wasn't actually 1 unit that the space is expanding. It's 1 million units. That it's 1 million times more that it is expanding. And my main issue here was originally I added 1 and did not think of it as doubling instead of like I thought of it as adding instead of doubling. And so for part 2, where it's 1 million, I tried multiplying it by 1 million, and that did not work because you really needed to do it by 999,999. So fun off by 1 error.
Yeah.
Yeah, those are always great.
Yeah. And also, like, as I mentioned, the big number, if you try to do it like kind of the naive, just adding instead of multiplying, yeah, you run out, the solution won't run in a reasonable amount of time. So as something that I learned from a previous one, or maybe a later one, I don't know, these all kind of congeal in my head now, of knowing that you really just need the edges of it, like the min and max of what you're looking at, and disregard all the stuff in the middle, and then doing some kind of equation to find the difference between that is what got me the answer. But I'm pretty sure I didn't come up with that. I had to find that. I spent a lot of time on the subreddit this year for sure. But I think I did get it eventually.
Cool.
And I also made a class called Universe.
Yeah,
what about your classes?
That was my class, my Universe class.
Yeah.
I've noticed that most people do not build classes when they do these, but I just think object-orientedly. I can't help it.
Well, you've infected me this year. Well, infected sounds negative, but you've inspired me, because yeah, I also never made classes, and now several of my solutions have classes in them, and so I don't know what to say. That's just how it is now.
I have classes, but they aren't like what you would call good object-oriented programming. Like I have Elf Problem 1 and Elf Problem 2 as classes that both inherit from Advent of Code Puzzle that does a bunch of like preliminary work for me automatically, like grabbing the data and inserting them in and doing some common parsing that I often have to do, like either separating it by line or inserting it into a grid or stuff like that. And but my actual I don't have an actual like universe class for this. I just made a method in my elf problem that was like make a galaxy map.
Yeah, I think most of my main reason that I end up with, besides just it's the way I think that I end up making classes is it allows me to do things like print it out at any given moment, because I just have a like toString function or the equivalent of it in Python, which is just $_stir $_. And that way I can just print it out whenever I want, and that's how I did my visualizations. But I think you said you write them to a file or something and then post process that, don't you?
Yeah, I have a .vis function in the Advent of Code class that everything inherits from. And so if I'm using the data structures that I typically use, which I have like a grid class and a graph, which actually the grid class actually inherits from the graph. And so if it's in one of those formats and I do a .vis, it will pipe it out to there's a program called OpenSCAD. And this is mostly used for people like doing things like building parts or 3D printing, and the interface is code. And so basically I write this code to write code that then allows me to open it in this application, and I see all the cubes in 3D and whatnot.
Wow. That sounds cool. I feel like I want to check that out now.
Yeah, I actually, for one of the problems, I posted the code that writes the code. So if you ever want to go and plug that in.
Very cool. I can tell that this is the software has been around for a while because it still refers to Mac OS X. And also just looking like it looks like it was built in was it GTK?
Probably.
Yeah, just
it is open source, but I have never actually looked at the source.
Those things that are cross-platform always tend to have that GTK look if they're not Electron, and this would probably not be a good thing to write using Electron. So that's cool. Yeah, thanks for that note. So should we move on to day 12?
Yeah,
Matt, you wanted to take that one?
Sure.
I definitely have nothing for this. I think this might have been the most infamous problem, at least up to this point. So I'm not going to have much to say about it.
This one ruined my life.
Yeah, I remember having a lot of problems with this. So the basic problem here, it's called hot springs on day 12. And, there's a whole bunch of hot springs, and some of them are broken. And so you've got this map of the hot springs that shows you which springs are operational and which ones are broken, if I remember correctly. And then after that, there's some basically like error correction bits where it says it's a list of the number of contiguous broken springs or something like that in a row. So you'd have like 113 is in their example. That means you have one broken spring and then another broken spring and then 3 broken springs. And then we have to figure out there's some errors in it. So find the errors using all of this. I think was basically what it was. And then so what we actually had to do was calculate. Well, okay, there's more than we might not know some of these because there's also question mark that would show up in the grid, and that meant we don't know if this is a broken spring or not. And so then what we had to do was look at the map and the error correction stuff and figure out how many possible arrangements there could be for each row. That was it was a real pain. Yes. I'll just give my thoughts on it real quick, and then we can go around. Parsing was fairly straightforward. I made a class called condition record to operate on each row. I had a big recursion method that I ended up having to make a class method to translate question marks into dots and hashes so that I could try to figure all these things out. And then I verified every possible string from the above recursive method and then split it up by uh, the empty tiles or the non-broken tiles, whatever dot was. And then I could compare that against the results that I got, and I was able to come up with it. It was not exactly efficient for part one at all.
Yeah, I sort of did it similarly. Instead of a recursive function, I did do it iteratively, where there's all of the unknown ones are marked with a question mark, and so for every question mark, for part one anyway, I tried every single possibility of question marks, and I had a matching function. So I would just go and see, does this fit? Does this fit? Does this fit? Does this fit? Etc. And I knew that whatever part two was, that was not going to work, even as I was writing it, because like part one has taken a good minute to 5 minutes to run. This is not going to work for part two.
Yeah, I had very similar. Mike, you said you didn't get to part one on this one?
No, so I will just say this: the reading of the problem made my eyes glaze over. A lot like day 5 with the seed growing thing, and I even looked at a solution / tutorial someone had written on Reddit for this, and I said I'm still not sure how it works. So yeah, this was a big old failure for me. I just skipped it. So you guys, I am curious to see what part 2 is. So please spoil that.
So part 2, they're like, oh no, the map was folded up. It's actually 5 times bigger or something like that.
Big numbers.
Yeah, so make it bigger. And that instantly killed my solution for part 1. I was just like, no, this is never going to finish. I ended up doing dynamic programming, which I don't enjoy writing dynamic programming. It's counterintuitive.
Now, can you explain what you mean by that?
It's where you like make the problem smaller, basically, and then solve it smaller so that it reminds me of doing proofs by induction in math, but kind of in reverse is the closest I can come up with how to describe that. I don't like it. I tried it first just memoizing my recursive function, so just storing state, right? Like, okay, when it looks like this, it's this. And it didn't help. And so then I think I looked online to see what people were doing. And I was like, oh, yeah, dynamic programming, fine. And I broke it down and did something with that. I would have to actually go dig through my code to figure out what was wrong or what I did specifically. But it was definitely had to get rid of my recursive function. What about you, Richard?
So this one is probably the problem that I spent the most time on, because there were literal hours at a time where I thought that I was 5 minutes away from solving it.
Yeah.
I knew that the initial way wasn't going to work, and so I devised what I ended up calling the wiggle method, where basically I would go and I would try and find the first location where each group would fit furthest to the left, and then take each of the groups and move the furthest one to the right, and then go back through each of the previous groups and try and see if they could move to the right, etc. And this ended up branching a bit too, where one can move to the right, and then maybe an earlier one can move 1 or 2 to the right. And so for the 1 or the 2 in that group, each previous group has to go and to be determined if it can move to the right, etc. And this was way faster, but not fast enough.
Oh my gosh.
I actually looked back at my solution. Turns out I did not get part 2 for this one. I never got to the point of it. In fact, when I came back from my trip, I looked on my whiteboard, and this was the problem that I'd been trying to figure out. So I'm glad you managed to make it work.
Yeah. So then after that, I had like, oh geez, let me scroll through my solution. I have 600 lines of code for this.
Oof.
Most of which ended up not being used in my final solution. I think there's about 100 or 200 lines of code that actually was used. But I went through trying to find, like when you move it to the right, like how much, where do I have to do the cutoff, and where do I have to like do the substring and everything like that. And eventually it got so complicated that I just like, I am just going to rewrite this. And it was my rewrite where it basically worked by taking each possible location of the group and finding all of the solutions left of the group. And for each of those, I would cache them. And it still worked in the way that the wiggle method worked, except that for all of the except that it divided it into sub-solutions to the left and had to cache those sub-solutions. But it still needed to go and move things slowly to the right and wiggle along, essentially. And that ran essentially instantly. So it went from being that I could not even solve the sample problems with the original method to being able to solve to almost being able to solve the sample problems with the original wiggle method, to being able to solve it essentially instantly with the divide and wiggle and conquer.
Divide and
Man,
wiggle and conquer.
If only some of the great war generals of the past knew about the divide, wiggle, and conquer method.
Yes, exactly.
Love it.
And for a little while, like I thought I might be able to do it with my original wiggle method, because I looked at the sample data, and if you do it for a subset of the unfolding, then it follows a pattern where each one it was a different multiple, but it was a multiple of the previous solution. And so I'm like, all I have to do is like go 3 in and I can find that. But it turned out that worked for the sample data, but not the actual data. And so that was very disappointing.
I was going to say, this definitely felt like a year where there was a lot more. You need to go in and look at the actual data and find the pattern that's in the data, and not like do the algorithm that it's telling. Like you can make assumptions based on what's in the data than in past years. I might be imagining things, but that was when you were describing.
Yeah, I thought that was going to be this after my after my second attempt failed. But as I was running that, I wrote my third attempt, and that was fine.
Nice.
So I was trying to use my second attempt to make more predictions about the data, and even I think it's a total of 5 times longer that the actual result needed to be, but it wasn't sufficient to do the 3 times longer because of the initial offset, and my 4 times longer was taking forever. And I still wasn't 100% sure because all the original data did actually work with just 3 iterations. Anyway, it was a mess, and it ruined my life, and it was horrible.
At least you got it done.
But I did get it done.
I'm curious, like, I think Matt and I have only done this year, 2022 and 2021, at least actively as it was happening. But have you done previous years as they were happening, or only after the fact?
So I have done exactly 1 more year than you guys during.
Okay.
My first year was 2020 for doing it live.
Okay, and would you say that this is like one of the hardest of the 4 years you've done? Because the amount of like chatter that this one created online seems like a lot for this year, but I don't know if it compares to all previous years.
This was definitely the most difficult year, at least for me.
Okay.
I think that my theory is that they ramped up the difficulty because of people using AI, or expecting people were going to use AI. And they were like, okay, how can we make it so that they can't? And now it made it so that my non-artificial intelligence couldn't do it either.
I've heard that. I've heard that too, but I haven't seen any response from Eric Wastel, the creator, one way or another. So who knows?
Who knows?
Yeah, for a couple of the previous years, like I tried to get my kids to do it. And like it, I mean, basically I would go and hover over their shoulder and they would try and figure out the logic and I would help them with like any sort of syntax and whatnot that they needed. And this year, after doing the first problem, like, this is not going to work. I'm not even going to try and have them do it this year.
Yeah, I like the difficulty of like the first half of of each year usually, and then the second half, I'm like, no. And this one, I felt like I hit that wall a little earlier.
Yeah, I went back when this year was over. I went back, and I'm still sort of on and off trying 2015, which I had started probably after last year's event, just to kind of like see what the difference is. And it's interesting to see how it's not just in your mind. Like this year, the difficulty ramp is definitely different because I've gotten through the first, except for like maybe one problem that I had to skip, I've gotten through the first like 12 or 13 of 2015, and there was definitely nothing with this level of difficulty, especially even just on part one. So it's definitely getting harder. He's getting more intricate at writing the problems. It was interesting, a lot of the 2015 ones, the input is not even like a link. Usually the input is like a link to a file full of stuff. Several of those are like literally on the page. Like you don't even have to click because the input is so simple. It's just like, here's, it's like find out the next password in the series based on these rules, and here's your password, as opposed to find out, the next 100 password, increases or something. So
what is the 10 millionth password that you might encounter?
Exactly. I mean, there is like an MD5 kind of hashing problem, which, definitely could have an optimization thing, but it's still just find the next thing in this one or something. But anyway, let's move over to the next day, which hopefully did not ruin Richard's life. And that's day 13, which is called the Point of Incidence. Now, this one, I definitely put in some work on it. I was not able to get it, but I did. But I do have code written, and I'm looking at my code, and there's at least an attempt at it. But just to sum up, basically what it is you're given some data that has dots and hashes, and you're trying to find the point either vertically or horizontally on it, where if you were to flip it over on itself, it makes a mirror. So basically trying to find mirror images of data. And this feels like something that has an algorithm that's obvious to figure out data that has that point of incidence, but I didn't know what it was, so I was just, kind of doing it naively, as I will keep using just as when you don't know the super math shortcut, you just like going through each line and checking to see where mirror images occur. I was not able to find anything beyond that, so I'm curious what you guys did to solve this one.
I can go first.
Go for it.
I had 1 million off by 1 errors in this one. This was such a pain that I actually called it out in my notes. I just wrote so many off by 1 errors. My basic strategy that I ended up doing for part 1, which did not work for part 2, was to find all mirrored pairs that are adjacent in the map, and then count out and then grow outwards from there until I reached an edge. Because something that was not obvious to me by reading the problem statement, and I've gone back and read it several times and it's still not obvious to me, is there were multiple places where you might have a row or a column mirrored, and it might even go out a couple. But unless it reached all the way to the edge, it didn't count as being the thing. And that was not obvious. So I wasted a bunch of time around that. Once I got that out there, then once I was able to grow my mirrored pair out to the edge, then I just found the one that was, I think, the longest or whatever, or the biggest path, and then that was the one that we needed to use. Richard, how did you go about doing it?
Yeah, basically the same way. I went and tried to find one that was symmetric, and then once I found one that was doubled up, I went out and out and out, and as long as one side hit the edge, before they stopped duplicating, I knew that was the answer to that, and I just stopped after that point.
That sounds like what I should have done, but I did not do that somehow.
And then there was part 2.
So what's part 2, guys?
So part 2, they kind of combined with. It reminded me of the previous one, where we had like an unknown and we needed to figure out. But here, every single mirror, because the hashes that we were matching, I think, represented mirrors in this giant valley of mirrors, has a smudge on it. But they don't tell you where the smudge is. So you have to figure out, where is the smudge? And so to do that, you have to do basically everything you did before, but assuming that there might be a smudge somewhere. I didn't get this one. It looked really obnoxious. My first idea was to create like a matches function that takes in 2 strings and returns if they match, and if not, how far off they are, and then use that. And then the number of off areas has to be 1 at most. I was like, that seems like a good way to go. This one just frustrated me to even look at, so I didn't do it.
So Richard, inform us.
So for this one, like, so I guess like there's a hash that is a mirror and a dot that's not a mirror, and one of them is wrong. And so I did it the dumbest way possible and just went through every single thing and flipped it to be opposite of what it was, and then ran my initial algorithm to find where the symmetries were. The thing that threw me off, however, was that the original symmetry might still be there, but there is at least one additional symmetry with the change that is made. And so I had to keep track of the symmetries that occurred in the original solution. And if that one pops up, I have to go, nope, that wasn't it. That was one we already found, and continue looking. And then after that, like the next one you found was the one that you wanted to go and report on. And so I just did that for every single tile. I flipped it to what it wasn't and tried.
That makes
sense.
Okay. Yeah, I considered doing that, and I'm like, that's going to take forever, and so I just didn't.
Turns out this is one of the few cases where it doesn't take the end of the universe to try everything.
Yeah, I think this is about the point where I was on vacation for the rest of the year, and so anytime I did anything, it was during my like, oh, I'm stuck on a plane, or everyone's asleep and it's dark out and I don't want to go out because it's negative 15 degrees outside or whatever. And so if it wasn't fun, I often just didn't do it. So this one I was like, no, I'm not having fun doing this anymore. Plus I didn't have my whiteboard because I was in a different country.
And also for those listening, like, this is often about the time in the Advent of Code event where it starts getting to those points where you're like, if you're not having fun, it's maybe not worth it to beat your head on it. I mean, I stopped getting them in general at this point, but I did get a few. I got, it looks like, our next one we're about to talk to, 14, part of 14, both of 15, and I got 19. So it's one thing that I've had to remind myself that if like one comes up that you're just not, jiving with, that it's not like a rope. It's not a wall. It's just a bump. And really you should go over the bump because the difficulty can be totally different and you could totally grok. Like the next one, Richard, why don't you tell us about day 14, parabolic reflector dish? I found this one fun. And I think that's why I ended up getting at least the first part.
I also did.
Oh, this is the one where there are a whole bunch of rocks in the field, and if you tilt the platform, you can make the rocks all go to one side or another, running into various obstacles along the way.
Yeah, it was a little bit like a Labyrinth or Legend of Zelda type puzzle where it's like, okay, tilt this thing, all the rocks slide down. Tilt it this way, all the rocks slide that way.
Yeah.
Yeah. And so you need to go and calculate the load caused by it, which is essentially, let's see, how did you calculate the load?
It
It
was
had to
like
do
how
with
many rocks were on one edge of it at the end?
Oh, okay. So the load, each of the rows had a number associated with them,
Right.
and so the load was the number of rocks on a particular row times the row number. And you calculate, you add them all up to get the total amount of load. And so you go and you hit the lever, and did part one go all the directions or just one direction? I can't
just
remember.
north. It just tipped it north, and then you had to calculate the. Or
Okay,
no,
so
maybe it went all directions.
yeah,
once.
it was. Yeah, it does. It yeah. So yeah. Here's it. Start by tilting the lever so all the rocks will slide north. Okay, so all on part one, you just had to hit the lever and all the rocks go and roll to the north, and then you have to determine how the load is. Yeah, I think that's basically the summary. And so for me, I just did the simulation of rock goes until it hits thing, and then add.
That's exactly what I did.
Yeah, pretty much. Yeah.
I had a rock class and a platform class, and I just made them behave as they would.
Simulate world.
Just
Yeah,
move all the rocks until they collide with something.
I just had the platforms. I didn't even make a rock class because I didn't think the rock had sentience of any function.
I made the rock class because it made it easier to say move this rock north, right?
Oh, I see.
Move
Okay,
it west, and specifically compute load was a function I had on the rock, so I could just go through and like for each rock do this thing.
Wow, very cool. OOP in action, everybody. So we all actually got part one, but part two was another not only big number, but also now you had to do it all four directions. And
Yeah.
I believe I got I was able to use my code modified. I think I figured out all the directions in part one just because it seemed obvious that part two was going to be it was weird that it only went one direction, and that was basically a code smell for Advent of Code that they were going to make you roll it both, in west, south, and east as well, which they do, and then do it a ton of times. And I had the pretty much the unoptimized issue, so I was not able to get 14.2 because what I was doing was the brute force method, which did not work, at least in Ruby. So what was the proper mathy way to do this? I always wonder.
So it's not necessarily a mathy way, but I added a run cycle method to my platform.
It's like a washing machine.
Class. Yeah, well,
Exactly. That's exactly how I thought of it too.
They called it spin cycle.
Yeah. He knows what he's doing.
And then what I did is I kept a history of where I'd been so that I was able to detect cycles. Because what usually happens with these kind of problems is you move it. You basically would go, what was it, like north, south, east, west. I don't remember the actual order that it wouldn't be that order. Like northwest, southeast, probably. And then you would do it again and again and again. But eventually, all the rocks would end up at the same place at some point in time as they had been in the past. And so then from that, I was able to figure out cycles so that I could just jump huge multiples at a time instead of rotating 10 million times. It was what was the actual numbers? It was 1,000 million. It was
like a billion cycles. Yeah. I'll say, Matt, that because I've been doing 2015 in Python, I've been trying to think more Pythonically, and I really like that Python lets you put underscores in a long number, so it's easier to read. I don't know if I don't think Ruby does that, which is what I was doing this year in. And man, that's some good stuff right there. Every programming language should do that.
Yeah, because just looking at a big sequence of numbers, I lose track real fast.
Yeah.
Yeah, it's easy to do.
The big mistake I ran into in doing this problem was not making sure to start from the tilting 2 side first. Otherwise, they'd collide too early. So when I was actually figuring out where the rocks were going to go, when I was moving them, you have to start with the rocks that are closest to the side they're going to slide into. Otherwise, you might collide with a rock that's going to be moving. And it was just a dumb mistake on my part. And the second biggest issue I made was cycles don't have to go back to the starting state. They just had to go back to a state that they had been in. So my stop condition was wrong at first, and then I started just printing things out, and I went, oh, hey, it repeats there. Oh, that's on the third. Okay. So there's like, you have N before the cycle, then you have X cycles, and then A afterwards. Just to completely go arbitrary variable names. How'd you do it, Richard?
I did it, I think, essentially the same way that you did. Is I looked for a cycle and tried to figure out when after it repeated, and I went back to the beginning of the cycle and then did it an offset from there to like 1 billion minus the cycle count to get the offset, and then did the modulus math to get all the way back to a billion, which I think is the same way that you did it, right?
It sounds like it, yeah.
And then I hashed it in a really stupid way, just taking the entire string and the entire resulting string that for the thing, and hashed the whole thing. And
that's how I did it too. That's always the easiest hash. It's just like, here's a string representing the entire thing.
Yeah.
Awesome. I'm taking notes here on the things you guys are saying, so that I can eventually go back and look at these. I love that I have this website that I made with with all of the descriptions and my inputs and notes about it, because I never did that before, and so I don't have notes about what I was thinking about previous years. So the ones that I didn't get or almost got, trying to go back to them is probably going to be, it's going to be a lot harder to like remember where my mindset was there. So thank you, Matt, for starting me on that road to thinking about keeping track of that. And then thank you past me for making it a website, because that's what I do. So yeah, that's day 14. Let's see, day 15, Matt, why don't you take, and I actually got both parts of this. So yeah. Lens library, go for it.
I'm rereading it just so that I can try to summarize it, because it's a rather lengthy and complicated description.
Yeah.
Basically, you have our goal here is to get the lava production back up and running without melting everything down, and we get effectively just a sequence of letters and then a symbol and possibly a number, and those have specific meanings. But to start with, they were just like, hey, compute the hash value. And then they gave you an algorithm specifically for how to compute the hash. And it's like, take the first character and multiply it by 17 and then divide by the remainder. And then it was a silly hash algorithm, but it worked. Part 2 got more complicated, obviously. But
part 2 was the real problem, to be honest.
Yeah. To start with, it was like, run the hash algorithm on each step in the initialization sequence. What's the sum of those results? So it's like, did you get the hash algorithm right? Basically what that question asked.
Pretty much.
I thought this one was pretty straightforward, at least part 1. This is the first one I did on the plane. And I know this because I couldn't confirm my part 1 for like 11 hours.
You didn't have Wi-Fi? Come on.
Nope. I did it, and I was like, well, this is annoying. Because for a while I didn't have internet, and then for a while I didn't have access to my computer. But ultimately it was pretty straightforward. There wasn't much to part 1. I just ran each sequence through the hashing algorithm and summed it up. How'd you guys do it?
I was just going to say exactly that. Ran through their algorithm, summed it up.
Yes, I also did it the same way. I think the only gotcha on this one was not reading the description properly, because I think this was the one where I wasn't sure. Was this the one where I wasn't sure where like it started, or maybe that was a later one, and it was a really obvious one. Like, always start it at this thing. It was like one line in this incredibly long description that said always start.
I think this is the realization that you made in part 2 and then posted it to the group where you found that line.
Yeah.
So part 1 was not that.
Right, because I figured out the hash and I was like, okay, I can run this hash on everything, but like, how do you know where to start it? And I was like, I think I was doing it alphabetically, like by label or something like that, and I was not getting the right answer. I'm like, what the heck? And then there was like a thing, start at the hash of this thing label. I'm like, oh, and then it all came together. So yeah, this one was a nice reprieve, I guess, from some of the earlier ones, but also
sure.
just a cool problem. So yeah.
Yeah. Part two of this, they ramped up the difficulty considerably, but I still thought it was relatively straightforward. Where now you have uh, not only that initialization sequences and hashes, but you have all these boxes that things are going to go into, and you're trying to figure out where the lenses are going to go, and you're computing focal lengths and all sorts of fun stuff. And it ended up being more of a like a little programming language than just hashing, because then it was like, okay, if you see this type of symbol, that means it's if it's a dash, then you go to that box and remove that lens. But if it's an equal sign, then you go over there and you need to put it into that box. And then here's a label maker so you can write things down. So it became more complicated. And you were trying to figure out what, I guess there were lenses, ended up in which box total. And then we had to figure out the focusing power based on that. I think the biggest challenge in part two for me was understanding the problem. I think it partly I was very jet lagged, and partly it's just confusing. It was not super easy to read through. It's a long problem. And then I completely missed one line in it that made it so much more difficult to get the sample to work, which was the result of running the hash algorithm on the label indicates the correct box for that step, which was just, for whatever reason, I did not read that, and I got very, very confused about where things needed to go and started making assumptions and didn't do it. I also missed the word replace, as in place, and thought it was removing and re-adding. So I was like taking something out and putting it at the end, but instead you had to replace it in situation, which was, again, not super clear. This is one of the few I did not create any classes for. But it would have made my code a lot easier to understand if I had. Also had to realize that I had to only hash the label and not the whole string. So then the algorithm was step 1, get every lens in the right spot. Step 2, iterate through the boxes and the lenses in the box to get the focusing power.
Yeah, I made 3 classes. I made a box class, I made a lens class, and I made a step class. Which was mainly just for ease of use to see the process. I mean, I always add way more code in the beginning just so I can see the inner workings of what's happening. Because, I'll make assumptions like, oh, I did this right, and then I'll get the wrong answer. And I'll be like, oh, wait, let's put a print line in there, and like, oh no, that's not doing what you think it's doing. And then I have to go in and comment that all out at the end or get rid of it. So yeah. Okay, so I think we all agreed that one was doable. And now we're going to get to day 16, which definitely is where I drop off completely. I mean, not that I didn't attempt any of these. I do have some code for some of them, but I did not get any of them until 19, and that was just part 1. So I will read part 16, or day 16, and then turn it over to you guys. So this is day 16. The floor will be lava. Let's see. Oh, right. No, this one, I actually, when I read it, I was like, ooh, this is cool. This reminds me of this board game that I played that's laser chess, essentially, where you try to move pieces and rotate them against an opponent so that when you push the little button that shoots the laser out, it, binks and bonks off everything and hits their king or whatever Egyptian chess replacement they had. So I was like, ooh, that's cool. That's going to be fun to play around with. But looking at my code, I have a move class, a beam class, a tile map class, which essentially is a grid class. And I got lots of code on this one, actually. So I must have really tried, but I'm not sure where I ended up, but I don't think I got anywhere near actually. Oh, that's right. I spent so much time just trying to map out the initial data, but I never really got into the logic of hitting the different mirrors and splitters so that the laser would go different ways. I think I just ran out of time, and then I just never came back to it. So I think I know how to do it. I think I was on the right course, but I have no idea what the twist in part 2 was. So I will now turn it over to you all, since I think both of you got this one. Yes. So go for it.
Richard, you go ahead.
Sure. So the tricky part of this one was like, as you have the beams that are going through the little maze thing, they can be split and they can be put in a way that there are infinite loops. So you can't just go and follow the beam forever. And that took a little bit of annoyance to get around. I think in part 1, I set up a queue to process things, the next beam iteration, etc. And in part 1, I didn't feel like figuring out a good way to keep track of if I'm in a loop or not. And so I literally just took a random element from my queue and solved for that, and then hoped that after enough steps went by that it would be correct. And for part 2, that did not work, so I actually had to solve it correctly. But yeah, so that was my major issue for part 1 anyways, so the potential infinite loops.
Yeah, I ran into a similar issue, although I did end up solving it, but I ran into another issue that I didn't solve. So this was one where I took some time to refactor previous things. So I took my class that I wrote in day 14 for positions that was starting to make things a little easier for me to handle, like, can I go that way, or is it blocked, or, what happened? What's the coordinates if I move this, if I'm north of this position, right? And then I made classes for a grid tile, a pairing, which was a grid tile to a grid tile, and a grid. And my main process was starting at the starting tile and heading in the direction, add each next to be visited tile to a queue paired with the from tile, because you need to know where you were coming from so that you knew where you were going, so that you could figure out the direction. I kept getting very confused about which direction I was talking about as I was writing my code, if it was the inbound or the outbound connection or direction. And then to deal with the infinite loops, I eliminated all the out-of-bound tiles first, and then I had a history or visited list to keep track of pairings that I'd already seen. That was to avoid the infinite bouncing. Biggest issue was that the starting tile in my input was not a dot tile. It was
Really?
a mirror tile.
What?
But in the sample, that was not the case, and I assumed that it was going to be a dot, and so kept getting the wrong answer until I finally realized, oh, you might bounce initially. That was just a bad assumption on my part. My sample ran fast, but my actual input for part 1 took 87 seconds to finish. Never figured out why. I always intended to run it through a profiler to figure it out, but I was on vacation and I didn't want to.
I'm looking at my input now, and you're not the only one. Yeah, my entry point is not a dot either, so I hadn't even considered that.
Part 2 of this. So, Mike, you don't have part 2?
I don't know.
Okay, so part 2 of this, the beam could enter from any edge tile, and as long as it was heading away from that edge. And you can choose either of 2 directions if it starts in a corner, which means we need to try every single one, basically. So the beam could start on any tile in the top row, any tile in the bottom row, any tile on the left or the right, heading in those directions. And then our goal was to find the configuration that that energized as many tiles as possible, which basically meant the beam of light went across them. I wrote, I'm on vacation, or I'd have tried to fix my 87-second issue above in my notes. Instead, what I did is I just ran through every possible starting tile and direction, and I just let it run overnight. And then I returned the max of the above possibilities. I could have made it more efficient, but I didn't, was the bottom line. Richard, how'd you do it?
So for part 2, going in from any direction, I did the same thing as you did, is just starting from them all. I don't know if there is another way to do that. For part 2, I did have to take care of my other issue instead of, I realized that it was probably a bad idea to just randomly select something from my queue. And so I set up a map that kept track of what had been processed based off of the location and direction. And that wasn't hard, and I should have just done it originally, but I didn't. And mine didn't have the super long runtime. I don't know what I did differently, because it sounds like I essentially solved it in the same way. And yeah, I think part 2 there was one issue where I had forgotten to reset my map of things that had been explored between each of the runs, and I was not getting the correct number of things that were being activated, and that took a little while for me to realize my being dumb.
I think I actually did something similar. If not on this one, then on a past one. But I definitely remember running into the situation of like, oh, I'm counting things that are not true for this run.
Yeah. I did this. Solving that problem actually helped me solve problem 13, which I had not solved at this point earlier, because I realized that my error was exactly the same error of not resetting a map on problem 13.
So as someone who has not gotten this one yet, like, it sounds like it definitely was important that, your data structure is keeping track of all this stuff. Like you said, like where it comes in, what direction it's going, where it's been, where it's going to, from which direction it's going to that. Because I find that sometimes I always worry that I'm like keeping track of too much stuff, and so in the end, that's why it takes forever to run, and I'm not finding like, the shortest, most efficient path through the problem. But it seems like at this point on day 16, you really have to start keeping track of all that stuff to even get close to finishing something. Well, I think that's going to do it for part 1 of our Advent of Code 2023 wrap-up, day 11 through 16. We'll be back next time with the rest of the puzzles, day 17 through the end. We want to thank our special guest, Richard, for being with us today. He will be back for part 2. But you can also listen to other episodes of our podcast at hackingthegrepson.com. And until next time, we now return you to your regularly scheduled lives already in progress.